Now that we've talked about confidence intervals and looked at how to calculate one, we can think about how do we compare different measurements. Once we have, we've done a measurement, maybe you did a measurement and your friend did a measurement, and you want to know, do your results agree with each other to statistical uncertainty, to within statistical precision, right? Because you could measure, say, something, maybe you measure a value of 15.1 plus or minus 0.2 molar, well, maybe not molar, grams per liter, and your friend measures 15.5 plus or minus 0.3 grams per liter. Do these agree? Or did you get statistically significantly different values? These are the sort of questions that we want to be able to answer with statistics. Now we'll look at three specific types of comparisons, three cases that are mentioned in your book. And one of these cases has two different cases underneath it, of course, to make things more complicated. The first case will be comparing a measurement to a known value. And this is the simplest one. You measure something where the concentration is already known from either previous measurements or it was prepared with a specific concentration. And you want to know, does your measured value agree with that? Case number two, and probably the most common one that we'll use in this class, is comparing two measurements, each with their own uncertainty. And our final type of comparison that we can do is where we measure multiple samples but we measure each sample only once, and each sample has a different concentration, but we're using two different methods. And we want to know, do these agree with each other? If we measure the same set of samples using two different methods, they're all going to be slightly different from each other, but do the results overall agree? So we'll start with case one. Case one is the most straightforward case. So this one's pretty easy to do in terms of the math that we need to do. So for case one, find the 95% confidence interval, or whatever degree of confidence that you want, for your measurement. And then see if the known value lies within that range. All right, got it all written down. So if the known value lies within that range, then we have 95% confidence that our measurement that we did is accurate, right? Gives us the result that we expect. That's the known value we're comparing to. So for example, this is problem 4-22 from your textbook. Let's say we have a certified 94.6 ppm sample. And this is our known value. Somebody has certified it to have that exact concentration. And we measure values of 98.6, 98.4, 97.2, 94.6, and 96.2 ppm. And the question is, do they agree within statistical uncertainty? Okay, so the things that we need to know for this are we need to find the mean and the standard deviation, and we need to decide what value, right, what's the number of measurements and what value of t to use. Okay, so mean and standard deviation, the simplest thing to do here is going to be to open up a spreadsheet. Happen to already have this here. So our standard value here is 94.6. We have our measurements here. These are the values that are given in the problem. Our average is 97.0, and the standard deviation is 1.7. Then we can find t. We have 5 different measurements, and so our degrees of freedom is 4. This formula up here, this is a different way to find t besides besides using the table directly. This equals TINV. 0.05, you write 1 minus the confidence interval that you want. So it's a 95% confidence interval in degrees of freedom here. So that gives us the value of t. And then this is the formula for confidence interval. So we have B12, which is the t value, times B11, which is the standard deviation, divided by the square root of the number of measurements, which is 5. So overall, we get a confidence interval of 2.1 for a 95% confidence interval. Now our original measurement was 94.6 ppm. That's our known value. And so the range, for the range here, I've just added and subtracted this confidence interval from the average. So I took B10 plus B13 and then B10 minus B13. And the question is, does this value lie within this range? And the answer is no. So within 95% confidence, we can say, no, this does not agree.